Okay, continuing on in section 6.2, first page of the notes, we're looking at multiplying polynomials. And before we can become really comfortable with multiplying polynomials, we need to review our definition of exponents, make sure that we are remembering the product rule and the power rule. This should be somewhat familiar. If this is not something that comes back easily to you, get some help, get some extra resources, extra practice on this right away. You want to be comfortable with definition of exponents and the product rule and power rule very, very soon as we move on through chapter 6. So the definition of exponents, if you have x raised to some power, we'll call it a, x to the a, meaning a could be any number here. Then by definition, that is x multiplied by itself. It's not x times a, but it's x multiplied by itself over and over until you have that done a times. So an example would be x to the fifth. Would be x times x times x times x times x. That's x 5 times. Not 5 times x, but x times itself 5 times. X to the third, or x cubed, would be another example. X times x times x. 3 x's multiplied together. X to the 14th. As soon as these numbers start to get big, you realize the need for this kind of notation, because writing out x to the 14th by definition, x times x times x times x, on and on and on until you've done that 14 times. In the interest of ink, paper space, hand cramps, the chiseling effort it would have taken before paper was invented, all those things, you can see why exponent notation is a very efficient way of explaining or expressing repeated multiplication. So we're going to look at the product rule, multiply each expression using the product rule. Before we look at the rule, let's look at what it means by definition, because rules are just a way of expressing what the pattern that you see over and over again. It's a way to quickly and succinctly realize there's a pattern and there's a rule that can be memorized. But you don't always have to memorize the rule. You can always fall back on the definition, and that's a good thing to understand if you ever get stuck on a test and you can't remember or you blank. You can always fall back on the definition. So by definition, number 6, we have x to the 4th times x cubed, or x to the 3rd, times x to the 5th. By definition, what that equals is x times itself 4 times, times x to the 3rd, or x cubed. There's another set of x's being multiplied, 3 more. And then you have x to the 5th. So I've written all that out by definition. So what you have here is, this is your x to the 4th, here's your x cubed, and here's your x to the 5th. And notice that all these are being multiplied together, because that's what we were doing in the original problem. And then by definition, what is this as an exponent? Well, you would count. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's being multiplied together. So by definition, that's x to the 12th. Now, the rule then says, how did we get that 12 based on the 4 and the 3 and the 5 that we had to begin with? The rule says that we would add the 4 plus 3 plus 5. We would add the exponents. And you can always remind yourself of this rule by writing it out by the definition and see, oh, there's 12 total. How do you get 12 total with these 3 numbers? You add them together. So when the product rule says that if you multiply the same base, this number down here is called the base, and this number up here is called the exponent. So base and exponent. Same base, all multiplied together, you add the exponents. That's the rule. Now, make sure that you've copied this down. Again, if you have any questions about exponents, get some help right away to make sure that you are solid as we move through chapter 6. And then pause the video and try number number 4 here on your own. Whether you tried it by definition or by the rule, should have come up with an answer of y to the 20th. And just noting that when you just see a singular, it's y to the first. So by definition, it should have been 20 y's multiplied out here. By the rule, 1 plus 19 gives you the 20. You can see how the rule is an advantage here.